We don't have any homework, right? At least for our class. Okay, so quick remind. So last week, before we had a Labor Day long weekend, we went through the linear trend model, which is very useful. When you plot data, you find the data show there's a trend or linear trend, then you can choose this model. It's a pretty straightforward model. Ft equal to A plus Bt. And the formula is given here. How do you calculate the slope B and the intercept A? And later we spend probably like 25 or 30 minutes whole class to try to solve this problem by ourselves, right? With some help, maybe from our labor or maybe from me. We have solved this problem. We set up the linear equation given this historical 10 weeks data. And then we make the forecast for week 11 and 12. That's what we have done on last Friday. Remember? Okay. So today, continue our journey. Like I said, we will introduce a lot of models in forecast. The reason is that in the reality, you really laid so many weapons in your hand because you don't know which weapon is really fitting your situation in the future. So the next thing we'll talk about is called trend adjusted exponential smoothing. So let's first review what is the exponential smoothing method. We have introduced last week. So for the exponential smoothing method, the forecast Ft is based on previous period forecast Ft minus 1 plus alpha, which is the smoothing constant or parameter, times forecast error, which is At minus 1 minus Ft minus 1. That is the exponential smoothing method. Now here, we modify a little bit to get a more complex model, which is called trend adjusted exponential smoothing method. So you can see the difference between the name is that it has the trend adjust. So it's adjust the trend. Let's see how this new model adjusts our trend. So this method consists of two components. One is the smoothed arrow, where C is exactly the same as traditional exponential smoothing method. The second one is new for this model. It's called trend factor. Okay, so when we want to forecast the period T plus 1, so here is a new formula. TAF means trend adjusted forecast. For period T plus 1, we need to calculate ST and TT. Well, ST is the smoothed arrow, while TT is the trend factor. Let's see how can we calculate ST and TT. Okay. Well, ST is calculated this way. Last period forecast, TFT is the last period forecast. Well, now we're talking about make forecast of T plus 1 period. As is last period forecast plus alpha AT minus TFT. Okay, I want you guys to look at and compare these two formulas. So the top one I just write here is the exponential smoothing method. What we have done last week is pretty straightforward, right? So it's last period forecast plus the constant times the forecast error. And we get the next period forecast. That's traditional one. Now we are looking at the trend adjusted exponential smoothing method with this smoothed arrow ST. Do you see the connection between these two? Do you see the connection or the relation? Or no relation? Do you see that?
Well, they replace Ft minus 1 with the TAF.
Yes. In fact, it's the same. Because when we talk about TAF, it's just this symbol. You can definitely write Ft. You just erase TA. The TA means trend adjusted. It's a forecast, right? TAF only means, okay, that's a forecast is made by trend adjusted exponential smoothing method. But it's also a forecast, right? If we remove TA, then everybody is very clear. It's the same formula, right? So the smooth arrow here is nothing but the original express smoothing method without consider trend. So it's called a smooth arrow, right? So write TAF. The only thing new in this model, no, I know when you see this model, it may be a little bit scared, oh, it's so complex. But if you really look at ST, that's nothing new. It's just a traditional exponential smoothing method. So to get ST. But this is not the forecast. For this trend adjusting method, ST is not enough. We need to add the TT, which is the trend factor. Okay, that's new for this model, which TT is equal to TT minus 1 or plus beta, another constant, TAF minus TAF minus 1 minus TT minus 1. Okay, let me explain a little bit about why they calculate TT in that way. So TT is trying to capture a trend. The trend, there are two trends, increase trend or decreasing trend, right? So TT wants to capture, okay, what is the trend in the previous data? Okay, so how they calculate? The first has the previous period trend, TT minus 1, as the base. And then we add a constant that's between 0 and 1. So just remember, alpha, beta is always between 0 and 1, these two constants. So add this factor, let's say 0.5. Okay, that's the factor of beta. And you can look at this one. This one is the forecast between these two periods, right? So for example, if the next period forecast TFT is greater than TFT minus 1, which means it has an increased trend, right? So this will capture the trend, increase trend, but will modify by TT minus 1. So we initially has the estimation of the trend is TT minus 1. Let's say TT minus 1 equal to 3, right? But in reality, we find the forecast difference is 4. That means we have to adjust 1 because 4 minus 3 is 1 to adjust to add to TT minus 1. So basically, every time period we update the TT, we update the trend factor to demonstrate the latest trend by comparing our forecast and the previous trend. That's the general idea. Okay. It will take you some time to digest the contents of this method. Well, this method for some students may be the most complex method we will learn in this chapter. Okay, but general idea is that ST, nothing new. Don't afraid of ST, that is exponential smoothing. Okay, this is the TT. Oh, it's something new. But just follow this equation. Every day, every period, you update the TT. You get the TT, and then you get the TT plus 1, and moving forward. So that's the method. We don't have time to go through example of this complex model in the class, but there's homework question. You will have to do that, and also the example are provided in the textbook. Definitely, you can ask me when you have difficulty when you are doing the homework questions. Okay, next topic we'll talk about after we introduce the trend adjusted exponential smoothing method is about seasonality. So again, before we talk about seasonality, we want to first think about there's a lot of items, products have strong seasonalities. Examples, you guys?
Halloween candy.
Candy, right? Any other examples? Turkey. Okay.
Christmas trees.
Christmas tree. So you guys are just follow the calendar, right? What's the next? Present day? Probably no special. And
Chocolate for Valentine's, isn't it?
Well, yeah, that's the next one, right? Well, flowers, like chocolates, right? Or even if we're not talking about specific holiday, like summer, right? Swimming suits, or winter. It's all outdoor sports for winter. Spring, that's also summer, like ice cream, that's different stuff, right? So even you don't look at like Halloween candy, but still you will see the seasonality for, I would say, most of the product has the seasonality, most. It's very well nowadays, you see products, they have very, very stable demand every day or every hour. I can think probably chicken wings, but maybe it also depends, right? Some food, rice, maybe pretty stable. Water probably the most stable item, right? That's for the sale. But you look at, okay, McDonald's, they have seasonality. It's not like each season is like daytime, right? Lunchtime, dinner time, or definitely it's a peak time. So we make a forecast for McDonald's next hours, or what is our demand. Well, then you can't use like Layu method the previous hour, because next hour if it's lunchtime, right? Then we shouldn't use this model. We should consider seasonality. So you should realize, okay, seasonality is not just for like candy or turkey. That's where it's extreme seasonality, right? But for general products, they still have seasonality, like ice cream. We like US. When it comes to US, it's a little bit surprising that people eat ice cream no matter what's the weather, right? Even in Minnesota, in the winter in Minnesota, people still eat ice cream. But still, we have to say that's still seasonality for ice cream. You definitely eat more ice creams in winter, in summer than winter. I try to control the amount my daughter eats popsicle in the winter time because it's not healthy for her, but she still wants to eat. So that's a seasonality, which is by definition is regularly repeating movements in series that can be tied to recurring events. So usually expressed in terms of amounts, that's the actual demand, actual value, let's say demand, is very different with average. Like turkey's demand in Thanksgiving is much higher. I'm not a turkey fan. I probably only ate twice of turkey during my Thanksgiving. All this time I have to visit some friend. They cook turkey, so I have to eat. But if I had choice, I would choose some other products. But anyway, so turkey's demand, okay, in Thanksgiving is much higher than average, right? Similar like ice cream demand in winter, right? It's much lower than the average. So all this demonstrates the pattern of seasonality. There are two basic models we can capture seasonality. When talk about it's not easy. We can't use the Layu method, right, for seasonality, right? Can we use the moving average method? No, because you think about it, if we forecast the turkey demand, so how many weeks before we should go moving average? Doesn't make any sense. The past 1 year's turkey information doesn't make any sense to predict the forecast for Thanksgiving, right? Doesn't work. Linear trend doesn't work because it's outlier, right? So all the methods we have introduced so far is time series method. They're useless when we want to make the forecast with products having the seasonality. Two models can capture seasonality. One is the additive model, and another one is multiplicative model. Right? So additive model is very simple. So when we want to make the forecast for the high season or low season, we express as the quantity add or subtract from the time series average. So we calculate average. But we add something. We think, okay, turkey average demand is what? So maybe 100 pounds per day in this grocery store. And then we add like 500 pounds. That's our estimation during the Thanksgiving week. So that's how we make the forecast. Well, another method is called a multiplicative method. So in this method, instead of we add like 100 pounds of turkey into our baseline average turkey demand, we multiply. We say, okay, turkey's demand in Thanksgiving will increase like 500%. So we just multiply 5 with the average turkey demand. That's called a multiplicative method. So one is to add or minus something. The second is to multiply a coefficient. It can be greater than 1 or less than 1. So seasonal relative, why that's one slide is missing here? Okay, I have to guess this slide. I think this new version is miss one slide. Show you graph about seasonality. Okay, here we go. Okay. So now two models, right? Additive model and the multiplicative model. Then you may ask why we need these two models. In which situation we should choose the additive model? In what situation we should choose the multiplicative model? That's two pictures will demonstrate the reason. So if you plot the data now, as we have mentioned in the linear trend model. Before you jump to any model, you should plot the historical data. That's I learned from my faculty, from my professor when I was a PhD student. When I was a PhD student in Purdue University, in West Lafayette, when the first semester I was in Purdue, I chose a PhD level statistics class. So it's graduate level statistics class. Talk about linear regression. The whole semester use SAS to run linear regression. So the faculty is a female faculty originally from Canada. She always told us, okay, before you jump to any model, okay, you may be very confident about software, you might be confident about the math, doesn't matter. Plots. Before you do anything, just keep plotting. It's very easy. When I use Excel, it's very easy to plot. But what's happened after the plot? You can identify the method used, like we have mentioned here, linear trend model, right? If you plot the historical data, show the linear trend, then you go to linear trend. If the historical data is pretty flat, then probably moving average. Here is same. If you plot something like this, what should we consider? Seasonality, right? It's very obvious seasonality here, right? Similar here, seasonality. Well, we know that a linear trend or moving average doesn't work very well for this pattern. Okay, if we plot, we find this pattern, seasonality. But the first one, the top one, if we plot the historical data, we should use additive model. The bottom one, we use the multiplicative model. Now, I'm so thirsty, so I want to take a rest. I want to ask you guys, why? The first one is additive model. The second one is multiplicative model, or more specific, why we shouldn't use the additive model for the second picture here, the bottom one. Why this one? Additive model won't work well. Look at the plot. You will find that. Look deeper. You see the difference of these two historical plots. Do you see the difference? Or is it the same?
It changes almost exponentially in the multiplicative. It goes up.
Exponentially? Yeah. So what any other thoughts exponentially or no idea?
Well, the additive model looks like it stays pretty equal throughout the seasonal trends. And then the multiplicative model, it looks like it increases in its seasonal numbers.
Generally speaking, the wave, the fluctuation become larger and larger. Okay, maybe you can, as another type is smaller and smaller, but generally it's not stable. When you see the first one, it's very stable. So the peak points, the deviation between the peak point to the average is very stable, right, for each wave. But the second one, the fluctuation is larger and larger. Then we'll see what's the problem. Okay, let's say if we still want to use the additive model, what's the problem that's gonna happen for the second picture? The first one, that's pretty straightforward. Okay, it's stable, then additive model works perfect. Then what's happened for the second model? Right? So if we still use the additive model, right? So additive model, so which means the forecast, right? The forecast we want to make, FT, is let's say the average. Usually average is like you can't go several years, probably like last 10 weeks average, right? Whatever you choose, plus a constant. Let's say Turkey, right? Let's say 100. That's your demand. That's what you get from the previous experience. Let's look at that. This 100 you get is from previous wave. Or you think, okay, I plot data, I find in the historical data, the peak Turkey demand is only 100 pounds away from the average. That's your build model, right? But if you use 100 to make the forecast for next year, the year after, then it's not enough. It's clear? Because it's become bigger and bigger. Well, why the multiplicative model can handle that? Let's see why. So multiplicative model, on the other hand, will handle this in a different way. So it has a constant. Let's say the Turkey demand will double during the Thanksgiving. So it's like say 2 times average. Then what's happened? Because the average turkey demand also increased here, right? Clear? Year by year, it's all also increase. So the base, the average increase year by year, which means when you multiply by 2, the difference between FT and the average increase, because the difference is one average, right? Average demand, right? It will increase year by year. So that's the reason multiplicative model can handle it very well. If you see, okay, the seasonality in this pattern, the fluctuation is bigger and bigger. If it's pretty stable, like this one, choose the additive model. It's very straightforward, easy way. But unfortunately, sometimes we have to consider the multiplicative model. It's clear? Everybody clear? Yeah. So, but you can see that everything is really depending on our plots. If we don't plot, okay, I don't care how good you at math, right? It doesn't matter. Well, I can tell you, a math PhD, they can't find a pattern if they have a huge data set. They can't just look at number to find a pattern. They have to depend on the visual demonstration. So plot. It's pretty easy, right? Use Excel, very easy. So next, we'll talk about how to really calculate the forecast for seasonality. So seasonal relative is in fact a multiplicative model. It's the seasonal percentage used in multiplicative seasonal adjusted forecast model. So how to use in the seasonal relatives? So first, we have to get a clear picture of the non-seasonal component of data series. If we look at ice cream demand, okay, think about, okay, summer, let's say we can sell 100 units ice cream per day. In the winter, we only sell 15 units. Can you say in summer we are doing a better business than winter time? Can you say that for ice cream?
Yeah.
No, because it really depends, right? Maybe you should sell 200 in the summer, right? Maybe you only should sell 30 the demand, but it's because your promotion work very hard, you attract people in the winter. Or in summer, you are lazy or you whatever, you don't have enough ice cream, so you only have to sell 100. So if you look at this number, they're biased because they have seasonality, right? It's not apple to apple. You think about dealership, it's the same, right? Okay, you have the big discount. You sell like 10 cars in Labor Day weekend, but you only sell 1 car or 2 cars in a regular weekend. You can't say your Labor Day performance is better because you sacrifice, right, by the huge discounts or you enjoying the holiday. Same thing for Thanksgiving, Christmas. Every store probably they will enjoy, but it's not apple to apple compared to performance during the peak season and the regular season. Then we need to get a clear picture. We divide each data point like ice cream by 100 in summer. But if summer demand should be double the winter demand, then we use this 100 divided by 2. That will be the demand without the seasonality. So we remove the seasonality factor. Then we incorporate seasonality into the forecast. We get the trend estimate for design period using a trend equation, linear trend equation we have introduced. Then we add this seasonality finally by multiply the trend estimation by the seasonal relative. Okay, when we talk about this method, it's not easy to understand. So definitely an example is very useful. How to use the seasonal relative to make our forecast? You'll see. So this example is apples. Citrus fruits farm ships box fruits anywhere in the world. We have to use the following information. The manager wants to forecast the shipment for the first 4 months of next year. Remember here, first 4 months of next year. Well, seasonal relative is given here for each month. You can see for these products, winter time is pretty popular, like December 1.4. That means 40% more than the average. January 1.2, 1.3. But for the summertime, right, it's not has a high demand, right? 0.7, 0.8, 0.6, something like that. And we already know that if we remove the seasonality, okay, it has the trend equation, linear trend equation. Well, Ft, the period T, equal to 402, okay, box, plus 3T. Well, T is equal to 0 is the January of last year. Well, you guys, you have to figure out, okay, if t equal to 0 is January for last year, then we want to forecast the first 4 months of next year, begin from January for next year. Then, what is the t value of t we should implement? We should plug in this formula. Think about, right? T equal to 0 is last year. Then we want to forecast the January for next year. Then what is value of t? And also, how can we get the seasonality? You can do that. I will walk around, try to help you guys. So if you have slides for this example, you don't need to de-seasonalize the data. So the first step, we don't need to do that. For this example, you just use the second step, incorporate seasonality in the forecast. You already have this trend equation, right? You just plug them in, and then you multiply the seasonal relative, which will give you the forecast. Take your time.
Since the tape is in January last year, that's considered January last year.
T equal to 0 is the January of last year. And what's the t value for the January of next year? First, the thing says you already have the trend equation. You want to figure out the t, the value of t, to plug in this equation.
We just one.
Yeah, t equal to 0 is the January of last year. And t equal to 1,
2, 3.
Yeah. That's right. So this t is the time period, right? When you plug in this 1.2 is a season relative, it's not t. T is an integer number. 1, 2, 3, 4.
So the T is,
It's a linear trend, it's t. So it's time period.
so the next year would be 1.
No. T equal to 0. So T represents the months, right? T equal to 0 is the January of last year. Then what does T equal to 1 represent?
February.
February of last year, right? T equal to 2,
March.
March of last year, right? Then you have to figure out what's the T value of the first 4 months of next year. It's clear?
It would be like 13, 14.
So
Wrong.
January 0.
13 is
January
wrong.
this year is
12 is also
February
wrong.
is
You guys,
So
be
you're
careful.
12.
It's elementary school math, bad.
So January.
T equal to 0 is
Right.
last year. We are talking about
1, 2, 3.
next year. That's 1 year between last year and next year, which is this year. Clear? Right? It's not just 12. It's 24 in fact. If you read about it, right? You can count, right? But very simple. If you count T equal to 11, that's December of last year. 11, right? Then what's happened T equal to 12?
Sure.
It's January
I'm
of this
I'm
year.
using this as a
Okay,
Here.
clear? So that's something, okay, it's It's
equals
look as very easy, but just pay attention,
times
right?
3 times 13.
So you need to figure out the value of t for the next year's first
Each month, you add January
11
Okay.
last year.
t equals 0.
So the next January is 12
Wait, you said it was 11, so what's
That would go
because you started with
last
0.
right?
If January is 1, then you go 12 months in a year.
March.
If you 1 to 12,
Always remember
January
March
is 0,
just March of last year.
0 to
Oh, then you add until
and
t
then
to 11.
next year is
That
12.
means December
This
of
year.
0 to 11 to 12. Right? Now
January is 0, February is 1, March, April, 5, 6, 7, 8, 9, 10,
Oh,
December is 11.
this year, right?
January of next year.
But we can't see. Because we are not looking at this. We're looking at which is
That was, I was thinking it's 12 months in a year, but
which means
that would have been right.
12
If
is
January
January
is
this
1,
year. Now what is
January is 0.
January of next year?
Subtract.
12 plus becomes 12.
And
Right?
February is
So the t value is 24.
March
January
is 14.
next year. And t is 25. February. Then you can plug in this t value.
So you just plug those numbers into that simple equation.
Kind of?
Row
Okay.
2 plus
I'm
3 times 0
Now what happens then?
equals 4 over 2.
Alright.
The zero there
And-
last year.
So if 30, so it's 402 plus 36.
That's
If I don't
January.
be driving back Sunday,
January.
there's still, I'm
That's
not
January,
going.
right? You still need to figure out February.
Are these three?
That's what I'm
Yeah.
thinking.
Yes,
I don't know,
yes.
I may be wrong, but if I'm plugging those numbers in.
Yeah, they're very I know, I know of her, but I don't talk to her. I know Brandon's brother.
Oh, you already got that?
Nice.
You figure out the t value of the
Yeah,
January
I'm only not.
next year? What is the t value? 24?
Oh, well,
Yeah, once you figure out the t value, most students already figure out, okay,
that was an early comment.
what is the t value for January of next year?
12.
24. 24.
Okay,
24, yeah. It's not 12 is the January of this year. Between last year and next year, that's this year. Don't forget this year, right? When we talk about last year, think about, okay, 2017.
Oh, January.
Right, yeah, it's last year. We talk about 2016 is equal to 0. And we want to focus on 2018. Never forget about that.
This year.
That's English make us confusing, right? So
T is always January last.
yes, t equal to 12, right? And then plus another 12, which is January of the next.
Now I see.
Good, good.
how do you know?
Okay, once you plug in the t value into the equation, this knows the end of story. We haven't considered seasonality. How can we do? Right? Questions? Okay. Yes. Huh? Yes, exactly. Because you have to multiply. The general
First T is going to equal.
demand is 20% higher than the average. So this trend is just we have like an average. So it's average means okay, every month is equal by 3 blocks. But they're doing good business. But this definitely can't capture the seasonality. You have to multiply
January of last year,
seasonal
January
random.
this year.
Very good. Then you do the same thing for the February, March, and April.
January is 24. So you plug the notes that you put
Got that?
24 and
24.
25.
This knows the final answer. What is the final answer? That's my question. So this model only captures the average trend. So that means like every month, average speaking is equal to 3 blocks. Shipping
January.
3 additional blocks.
February, March.
That's a very strong seasonality here. We have this big table. That means when you get the forecast for like January, February, you have to use this
you just plug it
number
into
to
the
multiply the seasonal random,
Okay.
which demonstrates the forecast with
So
concentration.
24 equals 402 plus 3 times 23.
No problem. Take your time. Dylan? Almost done.
Maybe.
Yeah.
You multiply? You do multiply? Multiply 1.1.
I did 1.1 by accident.
There we go. I'm sure that's what you're
I did 1.1 by accident.
Okay.
Times 25, which is 75.
Looking at April.
Okay. This is not the end. No, it is done. That's too easy, right? Have we ever considered seasonality if you just stop taking Oh, you are?
Multiply by relative.
1.2, 1.3, 1.3, 1.1.
Well, I thought he would mention days.
What about you?
I got this far.
Okay. Ask the labor. He already finished.
Yeah, is that correct?
Who is this?
That's the
Yeah, that's the first part. But finally, you have to multiply the seasonal rent for each month. And that means okay, generally it's 20% more than the average. If that's the average forecast. So if that's we don't consider seasonality, that's 474. That's right. For each month. That's why we give the season rent for each month. Okay. Take your time. You have plenty of time. Lots of time.
Yeah, next year. Okay.
I don't know. I've come. That's what I'm asking. So I got 474, 77, 180.
Okay, so you see with two complex. So this means with these
Right, 480.
these ratio we have to talk about. That's January.
That's what I thought.
Okay, then you plug them in. Once you plug them in, it's one more you guess. Then you plug
I'm a seasoned player, like down the street.
Then you plug the general wage is 1.2.
So you can multiply that number times the season relevant. So
David Johnson and
Yeah, you didn't listen to us. Why 24? Your T equal to 0 is the general wage. Then T equal to 12 is the January of this year. And plus another 12, 24 is the January of next year. Right?
bro, Willie Snead hurt, man. He the second receiver for Drew Brees.
Clear? Yeah.
Come on, man. That's why y'all lose. Oh yeah, y'all niggas was right.
So when
I just thought he was gonna leave.
Disneyland, we don't do that in this example because the reason is that
But Chad Henne was drafted by the
well,
Jaguars.
Disneyland is useful when we build this forecast FT equal to 402 plus 3T. Yeah, you think about it, yeah, when we consider linear trend, we need the historic data, right? How we get this 402 plus 3T? That's you first decentralize data and then you run the linear trend equation get. But this step already jump. So I already give you this linear trend equation. You don't need to decentralize. You only plug in. Otherwise, we'll take the whole class to do the example. If you, I give you the historic data and you decentralize and you build the linear trend and then plug in and multiply the seasonal relative again. So that's too much. But you understand, right? We don't use the first class. Yes? Rings?
I think I got it.
You got it.
Oh damn.
This is not the end of the story.
Suburbs.
So this is the
State
forecast
Board.
without seasonality. It's
Mo Brown, okay, this is just
right?
Yeah.
We
Lamar Miller?
information we are
AJ
giving
Peterson?
here, you use that, right?
Oh, he's not. First of all, Dempsey Foreman might take his money.
Multiply the seasonal relative.
Adrian Peterson.
It's already given. It's already given here. Yeah.
Don't get me to.
I'm actually.
If not, I'll
That's the question we're talking about, how we can find a seasonal relative.
talking
This
about every
we're
down.
talking about the second part. Once we have it,
Seasonal relative.
I don't. Not when everything.
well, you can, when you think about it, there's no way you know the seasonality of Max. what you can do is season relative on this.
I live.
Estimate the season relative next year. Because
Allow
no
power,
change.
brother. You gotta pick
If you say that forecast, every forecast is wrong, right? You never know what's happening next year. So what we can do best, season relative this year, is to make the forecast. No, you should update. I agree with you. You should update. Probably this season relative you get from last year's data. Right? Because this year,
Now, some
let's say you
stores
made a
they
forecast in the middle, in
in
September. This year has no confidence guess the season relative. But that's whatever season relative you can get. The most accurate one is here. Then you use that. Okay.
Alright. Okay, my only question is, do you automatically round up because you're talking about boxes of fruit? Even if it's low, would you say plus 32?
That's fine. You can. You should round, but some people will round down or round up. It's fine. But the key point is round. Because you are right. It's round.
So you don't want to be short of box.
I don't want to run it back.
You want to make sure.
Makes sense. I would argue is you don't demand it like 5.0001. You still want to send by this person, right? So it's either way it's fine. It really depends, right? But you are right. You should run for this Joseph, finish?
Yes, I believe so.
Alan will teach you a lesson. Not today.
Alan, right?
Try and make some.
And we're wrong.
They weren't this way before.
You are 99% correct. Okay, everybody here?
Math 14 is not gonna get all that.
So I need a volunteer to tell us FT, well T equal to 24, which is T equal to 24 is equal to what?
We had some like.
24 is the nobody?
Oh, 500.
January of next year, right? Okay, you plug them in.
But never touched.
What you get? FT F24.
474.
4 70.
4.
Oh, okay. So it's 24, and then we do the same thing. F25 equal to what?
477.
477. It's pretty easy, right? F26
480.
480. F27.
483.
So those correspond to January, February, March, and April of next year. The first step is can be. Many people will get a mistake, okay, to figure out the t value, right? But that should be the easy step, just be careful. Okay, later. Is that the forecast we should get? Is that the final forecast? No? What should we do next?
Multiply by the seasonal relative.
Multiply by the season relative. So this multiply by 1.2 for the January, multiply 1.3 for the February, 1.3 March, and 1.1. And who can tell me for January what is the forecast?
568.8.
568
Five.
point or 68? 68 point what?
8.
Point 8? Okay. February?
620. Oh, sorry.
620. 620? Point?
1.
Point 1. March?
624.
624? Points and nothing?
Yeah,
Points nothing. And April?
531.3.
531? Point? Okay. Alan, do you have anything you want to share with us?
Get around.
Are they right or?
No, you don't want to sell half a box or part of a box because you're selling boxes, so you get around one way or another.
That's why I work around and tell some students, okay, your final answer is 99% correct, except we're in the school of business. If in math, I would say, okay, you are right. Okay, math student will argue with me, we want to sell 0.125 box. We can do that as a math student. So, okay, just send this part. But we're doing business. Well, the common sense is that, okay, we don't sell 0.1 box, right? Well, Alan asked me, so should we round up or round down? What do you think? If we will agree, right? You guys agree that we should get the integer number because it's box. Should we round up or round down?
Round up.
Round up?
To be on the safe side.
Round up?
Most of the time.
Kayla?
I said yes.
Yes, round up? Round up?
Not always.
Most likely you are right. Again, It really depends. So if you run down, run up, I will give you full credit. The reason I will argue is you look at that, the second one, right? 620.1. Run up means okay, you don't want to disappoint a customer. Your customer order like only 10% about, you still ship to them. But in reality, right? In extreme case, 620.00001. Will you still ship this 0.0001 box to the customer? Most likely not. You will say, oh, wait for another week, right? Wait for another season. So that's so. So I know that I'm too picky because I'm from math department already. So when it comes to scenario, okay, common sense is common sense, right? We know that it's integer. But round down, round up all makes sense. It's really your choice. But you guys definitely right. In the most situation, we round up. Right, most situation we run 1.2, 0.3. We don't want to disappoint customer. But think about extreme case. It's not always round up is correct. So, guess integer number, round down, round up, both accepted by me. Right. Any questions for the seasonal relatives? No question. Okay, then we'll see you guys on Friday.